Good morning to all. Today we will discuss very fundamental topic and a higher pair mechanism which is commonly used in machineries, transmission devices, which is known as gear. So we know that transmission devices like belt, pulley and chain drives transmit the power between the two shafts, but having a major drawback which is associated with these transmission devices is slip. So for a particular object like a to transmit the constant angular velocity ratio, we use the gear. So that's why gear is known as positive drive. Gears are broadly classified into main four categories based on the shaft arrangement. One is the spur gear, second is helical gear, third is bevel gear, and fourth type is screw gears or worm and worm gear. On the basis of shaft arrangement, we can say that the spur gear and helical gears are used when the shaft conditions are parallel to each other. Bevel gears are used for the intersecting shaft, whereas the worm and worm gear are used for non-parallel or non-intersecting shaft arrangements. On the basis of the tooth profiles and tooth arrangements, we can differentiate further these two types of gear, spur gear and helical gear, which are used for parallel shaft arrangement In the case of spur gear, the tooth are parallel to the axis of rotation or the axis of shaft. Whereas in the case of helical gears, the tooth surfaces are inclined to the axis of shaft with some angle, let us say alpha. This is called as helix angle. Bevel gears are used to transmit the power for the intersecting shaft, which can be further classified into two types broadly. One is when the intersection between the shafts is perpendicular to each other. It means it is perfectly 90-degree. If the angle between the shaft is 90-degree and the size of the both the wheels are same, this is known as matter gear. Whereas if it is other than 90-degree, then this is called as angular bevel gear. Worm and worm gears are basically, this is work on the basis of screw. Worm is in the shape of a cylinder, whereas the worm gear, which is called as a wheel, is used to transmit a very high velocity ratio. So when we are talking about the velocity ratio, there are two terminologies which come into picture, and we should understand the difference between these two terminologies. One is the velocity ratio and the second is transmission ratio. Now the difference between the velocity ratio is the ratio of the angular velocity of the input shaft to the output shaft in a pair, whereas if we take the ratio of the angular velocity of the input shaft to the output shaft of a gear train, this is called as the transmission ratio. So there is a very fundamental difference between these two. But yes, we have to consider this. Now, when we are talking about the exact velocity ratio is basically used to get a constant motion, angular rotation of the wheels. If we consider the two friction wheels to transmit the power, one is smaller and the second is larger. Now suppose this is a input wheels which is pivoted with the bearing say 1, and it rotates in clockwise direction, whereas the output wheel say wheel 2 is rotating in counter clockwise direction. Now the power is transmitted between these two wheels is just because of the frictional grip between the two surfaces. So therefore it is subjected to a friction, which is, we know that F equals to mu into R, where mu is the coefficient of friction and R is the normal reaction between the two surfaces. So the distance between these two wheels is called as the center distance. Thank you. Thank you. Okay. So here we can see that in a single drive or a pair, this smaller wheel is known as pinion. If we cut the tooth on the surface of the wheel, input wheel and output wheel, then there will be an engagement between the tooth. It means the power is transmitted or the motion is transmitted with the exact velocity ratio. But yes, there is a condition which should be satisfied. In the case of gear, there is a fundamental law which is called as the law of gearing. Law of gearing is basically for the achievement of the velocity ratio, exact velocity ratio. Exact velocity ratio means, suppose if the velocity ratio is say 1:6, then at any instant this ratio will be the same. It is constant. It is constant. It means you can get the same velocity ratio at any instant. Okay, at any time you will find out the same velocity ratio without any slip. It is just because of the toothed wheels. Now, if we consider here a gear, since we are talking about the gears and the power or torque is transmitted due to the engagement or disengagement of the tooth between the two wheels. So therefore, if we take a free body diagram of a single tooth into consideration, now suppose if this is a single tooth, now this is the axis of rotation of the gear. If we find out an imaginary circle, now this circle is known as Swiss circle diameter. Swiss circle diameter is basically, it is the radial distance from the center of the axis of the rotation to the tooth. Basically the size of the gear is defined with the help of Swiss circle diameter. It is called as, in short, PCD. This is very important to define a gear size. Now if we draw a line on a face, we can divide this surface into mainly two parts. The upper surface is called as face, whereas the lower surface is called as flank. And there is a fillet radius, right? In order to achieve any stress concentration on the gear, this is a fillet. So basically this is the total height of the tooth, a single tooth. Now this topmost position Top surface is called as the top land. Now here what happening, while transmitting the power, this normal tooth is subjected to a force which is called as normal force of engagement, Fn. So here I am using a parabolic curve to define the uniform strength of the tooth. So during the engagement and during the power transmission, this is subjected to a normal force of engagement, Fn, which is resolved into its two components, vertical component and horizontal component. Its vertical component is denoted with Fr, whereas its horizontal component is denoted with Ft. Fr is a radial force or separating force which is directly transferred to the axis of the shaft. Now this is the position of the shaft axis. Whereas this Ft is which is perpendicular to the surface of the tooth profile. Now this force is responsible to transmit the torque. So the torque is nothing but this is Ft into the distance. Let us take this distance from the root of the tooth, say h. Now the torque due to this force is equals to Ft multiplied by h. Or you can say it is the moment, bending moment M. Now what is the purpose? If we are talking about the failure of the gear tooth, gear fails under two main categories. One is the tooth breakage, and the second is surface failure. Again, with the help of this free body diagram, you can see that the radial force is directly transferred to the axis of the shaft. So this force will be useful for the design of the shaft. It means the shaft is subjected to a bending moment and shear force and other forces. So this force will contribute while designing a shaft. This force will not be considered for the designing of the tooth. So because the effect of this force, a radial force, will not produce much stress on this tooth surface. But the major stress comes into picture when we consider the tangential force Ft. So therefore, we can understand that this tooth is behaving like a cantilever beam and it is fixed at this end, say section AA. Now at this section, we can see that this is the maximum bending moment which is at the fixed end. So under this bending moment, the tooth breaks. So initially what happened, this tooth breakage will start at the root. So suppose if it is subjected to in this direction, this force is say Ft. Now under this force, the initial crack will start and it will propagate over a period of time. So this crack will increase and at a certain time this will fail under the bending moment. So this is called as the tooth breakage. The second type of failure is called as surface failure. Surface means, see, we know that we have to design a surface with a profile. Why this profile is required? See, what happening, there are two profiles mainly. One is involute tooth profile and the second is sacroidal tooth profile, right? We will not much discuss about these two profiles because you have already studied in kinematics of machines. So this is the prerequisite of the subject, that you should know the basic difference between the tooth profile. Involute tooth profiles is popularly used in industries because of its manufacturing. The manufacturing cost is very less as compared to the cycloidal tooth profile, because a single tool, a single curve is used to generate a tooth profile. Whereas in the case of cycloidal tooth profile, we have to develop the two tooth profile. One is the epicycloid and second is hypocycloid. So means you have to choose here the complex tooth profile. For the simplicity, we use the involute tooth profile. So therefore, the purpose of this profile, which should be uniform throughout the section of the wheel, it means we have to form the tooth profile such that there should be a constant angular velocity ratio, and this action is known as conjugate action, and profile is also called as conjugate profile. So conjugate action is required to transmit the exact velocity ratio or constant velocity ratio. Otherwise, you will feel that sometimes gear will move fast and sometimes gear will move slow, which is not advisable, where the precision motion is required, like your watch, right? So if the gear is moving suddenly very fast, it will produce impact also. So therefore, it is required to achieve the constant angular velocity ratio. So this is basically the breakage of the tooth under the bending moment or bending stress. The second is the surface failure, which is further classified into few categories. One is due to the wear. As we know that once we generate a profile of the tooth, it should not damage, because if it is damaged, then this will not be capable to transmit the exact velocity ratio. So wear is basically, it is a type of a surface removal. The material will remove from the surface. So on the surface, what happening? There is a friction between the two surface, or there will be a compressive effect between the two tooths. Now under this compression, or you can say sometimes there is a lubrication failure. So it will subjected to a very high compressive stress or compressive load, and similarly the material from removed from the surface of the tooth. Now under this removal of the material, the profile will break. So this action is called as non-conjugate action. Non-conjugate action. Now wear is basically two types. One is the initial wear, means it is just starting just because of the manufacturing defect. If there is any remain particles which are present on the surface of the tool, then the wear takes place initially and the material is gradually removed from the surface over a period of cycle. But what happening, this will also increase just because of the abrasive particle or foreign particle. Suppose if your gear train or gears are working without any casing, okay, in the presence of the dust particles, then these foreign particles will produce more wear, and this is called as the abrasive wear. Okay, it is just like a scratching of the surfaces. It is just like a scratching of the surface, rubbing of the surface. The second is called as pitting. Pitting is a phenomena. It is just due to the excessive load. Sometimes the load is increasing very high. Now under this excessive load, these two tooths may compress to each other. Now under this compression, this pitting occurs. Now just like a wear, this pitting is initially started and it is progressively increases over a period of cycle. So the purpose of the pitting is basically, it is just like a we can say that we can take an example. There are small holes, a small material removed which is on the surface, and under the presence of lubrication, these holes will enlarge. इट इज जस्ट लाइक ए, जैसे कि आपका बरसात के दिनों में गड्ढे होते हैं, बरसात होने पे वो गड्ढे बढ़ जाते हैं. इट इज जस्ट बिकॉज ऑफ द हाइड्रोलिक प्रेशर. So this hydraulic pressure is responsible to increase the dimension of the hole. Similarly, the same thing is happening with the pitting also. So pitting is the initial pitting and it is gradually increasing over a period of time under the presence of lubrication oil. Last is surface failure, is called as scoring. Scoring is again, it is due to the excessive load, and due to this excessive compressive load, two tooths will stick to each other, and because the rotation is continued, under this case this is unweld. So the first is these two surfaces are slightly weld with a spot, and it is unweld under the continuous rotation of the wheel. Continuous rotation of the wheel. So what happening, due to the unweld of the surface, there will be a small spots on the surface, and these spots will further increase and it will damage the surface. So we have to maintain the surface or profile of the tooth for the conjugate action and to achieve the constant angular velocity ratio. Next is very interesting, but it is not mentioned in any book. I just want to discuss with you. This is basically, if we consider two tooth, now what happening in this case, the load is transferred. Now one tooth will compress this tooth and the second tooth will put the reaction on this tooth. So what happening, there are a normal reaction, say N, between the two tooths. So what happening, if we consider this force will try to bend this tooth in this direction, and this force will try to bend this tooth in this direction. So this is a elastic failure of the tooth, a small deformation which is called as the elastic failure. Okay, if we consider the modes of failure of any element, it is broadly classified into three categories. One is the elastic failure, the second is the plastic failure, and the last one is the fracture. It is completely breakage of the element. Similarly here also, if we are neglecting this elastic failure, but since this is very less as compared to the other loads, so we can neglect this type of failure while designing the tooth. But yes, so what happening in this case, if it is slightly bent in this direction and this will bend in this direction under the presence of the load, this is again non-conjugate action because the tooth profile will again disturb. But since it is very less and it is in the combination, then we can neglect this type of effect from the design point of view. So these are basically the classification of the tooth failure. Now if you want to design anything, we should know first the failure of the elements. Now since in the case of gear design, we mainly design the tooth. Now the tooth is designed on the basis of the bending equation. Now first equation which needs to be considered for the bending failure is Lewis equation. Now what is this equation? Let us see that. A small derivation is there. See, we know that the maximum bending moment now we know that the maximum bending moment occurs at this section A. So the distance from this tangential load is say h. Now the moment is Ft into h. So therefore let us take m equals to, this is Ft multiplied by h. We know that the section modulus of the cross section of the tooth, obviously we have to take the cross section at this section. Now suppose if the thickness of the tooth at the root, let us take it is say T1, and the width of the tooth which is constant from the top to bottom is, let us take as a B. Now this is called as face width. This is called as face width. So the cross section will be B into T1. So therefore the section modulus of this cross section Z equals to 1 by 6 into B into T1 square. Now we know that the maximum bending stress is say sigma B, and this is equals to, we know that this is from the bending stress formula, this is equals to m by z. So let us put the values here in this equation. So this value will be Ft multiplied by h divided by 1 by 6 into B into T1 square. So when we rearrange this equation, this will be find out 6 into Ft multiplied by B divided by h. Ft into h is the distance, leverage distance, and this is B into T1 square, and this is equals to sigma B. Sigma B is the static stress. Please remember, this is a static stress which is calculated from the with the help of tensile stress uh, or tensile test for a specific material. Now, when we can rearrange this equation to find out the force Ft, Ft equals to sigma b into T1 divided by 6 into H. Now, if suppose PC is a circular pitch, this is another terminology which is used in the gears. So, circular pitch is the distance between the two consecutive tooths. It is constant throughout the section. Okay, so PC is the circular pitch, and let us multiply this PC in this equation. You will find out on multiplying and dividing by this PC, this equation will not be altered, and this is sigma b multiplied by b multiplied by this is T1 divided by 6 into H. So PC divided by PC. Now, in this equation, Ft equals to, we can say that this is sigma b into b multiplied by PC can be put, it is pi into m, where m is the module, and this is T1 divided by 6 into H into PC. This we can take in a bracketed quantity. So we can use this equation sigma b multiplied by b into pi into m, and this value can be taken as a small y. Now this small y is a Lewis form factor, a dimensionless quantity, right, which depends upon the pressure angle and the number of teeth. So in this equation, further we can see that this sigma b is constant. It is constant. But you can observe that this force during the engagement or disengagement, Fn, normal force, will change in its magnitude and its direction. And also its component will also not constant. These are also changing in its magnitude. Now the angle between these two is, say, this is theta. So therefore this Ft is not constant. See, we are not taking this force into consideration, so we will consider only this force Ft, and the magnitude of this force is not constant. It means your gear is subjected to a fatigue load or fatigue stress. Now this is a fundamental Lewis equation which is having a constant, or you can say that it is a fixed stress which depends upon the material, permissible stress. So we have to introduce here a velocity factor Kv, which is always less than 1. The value of velocity factor is always less than 1, and this velocity factor should be multiplied with the static stress sigma b. So therefore we can reduce the permissible stress value and then further increase the dimension of the gear to increase the strength of the gear. So this tooth should be having a sufficient strength against the fatigue failure. So therefore this is equals to sigma b multiplied by Kv into pi into m into b into y. Now this is a Lewis equation. So this velocity factor plays a very important role, and this is calculated on the basis of the velocity of the gear. Means whenever we design a gear, we should know that what should be the maximum velocity of the gear. In automobile devices also, automobile arrangement, we should know that what should be the maximum speed of the gear, at which speed our gear should work. So under this speed consideration, we have to first calculate the velocity factor. Now the velocity factor will have a 3 to 4 equations, and it is always less than 1. So depending upon the velocity of the gear. For example, if the velocity is less than 10 meter per second, then the velocity factor kV equals to 3 upon 3 plus V. Similarly, if the velocity factor is between 10 to 20 meter per second, this is equals to 6 upon 6 plus V. Whereas if it is greater than 20 meter per second, then or higher, then the velocity factor is 5.6 divided by 5.6 plus under root V. Now these equations are given in the design data book, need not be required to remember. So we can use, but the importance of this velocity factor to decrease this product value, to decrease this product value. Now this value is decreasing, the dimension will decrease automatically. So once we calculate the value of the face width, module, pitch circle diameters of both the wheels, it means the input wheel and output wheel, and addendum circle, dedendum circle, and other parameters which are required for the manufacturing. Now these dimensions needs to be checked under the surface failure criteria. This is the bending failure criteria, then the second is the surface failure criteria. Now what are these criteria? Let us see one by one and see the importance of these criteria. One is, as we know that this is a wear failure, so we have to check these wear strength. It is denoted by Fw. Now with the help of Buckingham equation, we can say that the wear load Fw equals to dP bk into Q. One should remember that pinion is always weaker in the case of wear load. So we have to take here the pitch circle diameter for the pinion. Here B is the phase width, K is the material combination factor or load factor, and Q is the ratio factor, which depends upon the velocity ratio and the type of arrangement. The type of arrangement means whether the gears are internally rotated or externally rotated. So here we have to calculate the wear load in Newton. Then the third type of loading is known as the dynamic load. What is dynamic load? Dynamic load is mainly due to the error present on the surface of the gear tooth. Now these errors are responsible to increase the vibrations in the drive, and the dynamic load will increase. Now under the dynamic load, the gear tooth may fail. So it is required to check under the dynamic load also. So dynamic load is denoted with the Fd. So therefore the dynamic load can be calculated. This is equals to Ft plus Fi. Ft is the initial load, which is called as the tangential load also. Fi is the additional load. Now this additional load is due to the error, and the value of this Fi is equals to Ft plus 21V into Bc plus Ft divided by 21V plus under root Bc plus Ft. This dynamic load may occur or may not occur. It depends upon the cutting of the gear. If the gears are cutted precisely, then this dynamic load will not occur, right? But yes, if for the commercial gears, casted gears, there is always possibility of the additional load which comes due to the error on the gear surface. So this additional load should be added in the initial load so that we can calculate the dynamic load. Now for the safe design of the gear tooth, it is necessary to satisfy the condition that the dynamic load should be less than FBS. FBS is the beam strength. FBS is the beam strength, which is calculated. This is equals to sigma b multiplied by pi into m into b into y. Now here in the Lewis equation, the kV should be equals to 1. So we can put here the kV equals to 1, you can calculate the beam strength, and the beam strength should be greater than the dynamic load for the safe design. Similarly, the bear load should be greater than the dynamic load. Okay, and the third equation is the bear load should be less than or equal to the FBS or FT. So in order to check the surface hardness, why we provide the surface hardness? Because sometimes we want to reduce the cost of the gear. We use the composite gear. Composite gears means we have to use the hardened material on the surface of the tooth, whereas the softer material can be used for the rim. Okay, so what happening, we can use here the hardening process like a flame hardening or carburizing process to harden the surface only. The inside surface is soft. Inside surface is soft. Where the surface is hardened, and it will increase the wear strength. So in order to check the sufficient wear strength, whether the gear is safe in wear load, okay, we have to just calculate the BHN value, Brenner hardness number, and this BHN value will satisfy the requirement. Okay, after this, because this is a standard procedure which can be adopted for any type of gear, whether we design a helical gear, worm gear, bevel gear. Okay, so next is the complexity of the design increases when we fix certain parameters. For example, if we take the circles of two wheels which are called as a pitch circle diameters, of wheel 1, wheel 2, this will rotate in this direction, this will rotate in counterclockwise direction. The distance between the two centers of the shaft is called as the center distance. Let us take as A. Design parameters means you have to calculate the pitch circle diameters, your face width, module, addendum, circle, dedendum, circle, diameter. Number of teeth, number of teeth are calculated to avoid the interference. So interference is a phenomena where the gears can cut the material. One tip of the tooth can remove the material from the root also. So that we have to select the number of teeth in order to avoid the interference between the two mating gears. Now these parameters are variable, but suppose if we fix up the center distance, then we have to apply here one constraint. It means this gear is working under a fixed size or in a box which size is fixed. So what happening, once the center distance, because the center distance is equals to, we know that it is the pitch circle diameter of pinion, pitch circle diameter of gear divided by 2. Or you can say that mathematically in terms of module, this is TP plus TG divided by 2. So you can say that if this is fixed, then you cannot alter here the pitch circle diameter. एक को increase कीजिए, you can decrease the second one, right? Decrease this one and increase this one. This you can increase or decrease to change the RPM only. To change the RPM only. Module is fixed. Addendum circle and addendum circle can change on the basis of the size of the gear. But once you fix this center distance, your variables will reduce. Your flexibility will reduce. It means you have to design the gear under a constant. Similarly, if we fix some other parameters, then we can change only few parameters and other parameters remain same. So thank you very much. In the next class, we will discuss about the failure of the design in detail.